Hi, welcome back to GalaxyPhi Math. Please don't forget to like and subscribe. I hope you enjoy. Okay, so we have Steve and Ann here, and they decide that they need a beach vacation. So they decide to hop in their cars, their separate cars, and drive to the beach. And they stay on I-75 South the majority of the trip. And from the on-ramp to the off-ramp, it took Ann 6 hours, and it took Steve 5 hours. Steve drove 10 miles per hour faster than Ann, and we want to find out how far did they travel on I-75 South and at what speed or rate for each. We're going to assume that they did not stop to use the restroom or to get any food. This is unhealthy. Don't be like Ann and Steve. You should always stop and use the bathroom if you need to go, or get a snack on a long trip. Okay, so we know that Steve's time was 5 hours and Ann's time was 6 hours, and that Steve drove 10 miles per hour faster, so he had a higher rate. So we would have to add 10 miles per hour to Ann's rate to equal Steve's rate. And we also know that the distance is the same, so distance equals rate times time. So our rate times time for Ann can be set equal to the rate times time for Steve, since the distance for Ann is the same as the distance for Steve. And so we also have this equation, 10 miles per hour plus Ann's rate would equal Steve's rate. So we have 6 times Ann's rate, because the time will be put in as 6, and 5 times Steve's rate because Steve's time is 5, and we have RATA equals RSTS. So we're simply just plugging those times in for T. And then we're going to plug in 10 miles per hour plus Ann's rate and for Steve's rate, since those are equal. So we have 6 RA equals 5 times 10 plus RA. And then we distribute our 5 to get 50 plus 5 RA. And we bring our 6 RA down from above. We subtract 5 RA from both sides to give RA equals 50 miles per hour. So since we know that 10 miles per hour plus Ann's rate is Steve's rate, we're going to plug those numbers in to find Steve's rate. So we have Steve's rate equals 10 plus 50, or 10 plus RA, equals 10 plus 50, and these are all miles per hour, equals 60 miles per hour. So that will be Steve's rate. And so to find how far they traveled, you can pick either one, but we're going to do both just to show that they are both equal. So let's start with Ann's distance. And we're going to have, of course, RT, so Ann's rate times time. So Ann's distance equals 50 miles per hour times 6 hours equals 300 miles. So that's how far they traveled. And we're just going to double check and make sure that Steve's distance is the same. So Steve's distance equals 60 miles per hour times 5 hours. Which ends up being, of course, the same, 300 miles. Okay, so for this problem, there is a red train and a blue train. It takes the red train 8 hours and the blue train 12 hours to travel the same distance along the same path. The blue train travels at a rate that is 20 miles per hour slower. At what rate does each of the trains travel? Now this will be the same kind of distance equals rate times time. Again, you have the same distance, so that means that we will be able to set the rate times time equal to each other for each train. Okay, so we have our red train, we have our blue train, and they both travel the same distance using the same track and everything, same path. And we remember that our distance equals rate times time. And we showed this before, but here's another one. If you have meters, it equals meters per second times second. So you have your units of distance equals your units of rate times your unit of time. So it does cancel out and it works there. It works for miles per hour in the same way. And so since we have the same distance, we're again able to say R1 T1 equals R2 T2 if D1 equals D2, because they're equal to one another. You're essentially just setting them equal to one another to solve for one of those variables. So our blue train travels 20 miles per hour slower than the red train, and it takes 12 hours to get there, and it takes 8 hours for the red train to get to the same point. So if we're looking at RR, TR equals RB, TB, so that would be the red train rate, and the red train time equals the blue train rate times the blue train time. We also have our other knowns, which are TR equals 8 hours. It takes the red train 8 hours. It takes the blue train 12 hours. And we know that we have to add 20 miles per hour to the blue train rate to equal the red train rate. Since the blue train is 20 miles per hour slower, that means it's a lower number, and therefore you'd have to add it to the blue train time to equal the red train. Sorry, the blue train rate to equal the red train rate. So we have our red train rate times our red train time equals the blue train rate times the blue train time. We are going to plug in 20 plus RB for RR times 8, which is plugged in for our red train time. And then we have our blue train time times RB. When we distribute that 8 times the 20, we get 160. Then we distribute it to the blue train rate, so we'll have 8 RB equals 12 RB. When we combine like terms to isolate that RB, we're going to subtract 8 RB from both sides, and we end up with 4 RB on that right side of the equation. And we just bring that 160 straight down. To isolate RB further, we are going to divide both sides by 4. And so we have 40 equals RB. And that our rate for the blue train. And so the rate for our red train is simply just going to be RR equals RB plus 20. And so we plug in the RB as 40. So we know that our red train rate is 60 miles per hour. Our blue train rate is 40 miles per hour. Okay, so now we have a couple of Boy Scouts that decide to hike to the river from some starting point at a rate of 1.5 miles per hour. Then their scout leader decides, hey, I better pick them up in my pickup truck from the river because it has taken them a really long time. And his pickup truck travels at 18 miles per hour down the road to the river. So we want to find the hiking time and the driving time. If it takes 5.5 hours longer to hike than to drive down the road to pick them up. So again, we're dealing with the same distance to the river as from the river. So we will be able to set our rate times time equal to one another for the driving and the hiking. So that is what we will do. Okay, so the rate of the hike is 1.5 miles per hour for the boys. And the rate for the driving is 18 miles per hour for the scout leader that's coming to pick them up. And we know that it's going to take 5.5 hours longer to hike than it is to drive. So if it's 5.5 hours longer, the numerical value is going to be 5.5 hours more to hike. So we would add 5.5 to the driving time to equal the hiking time. And again, because we know the distance is the same, we will be able to set the rate times time of each to one another. So RHTH equals RDTD, where H stands for hiking and D stands for driving. So we're going to plug in 18 for our rate for driving on the right side and 1.5 for our rate for hiking on the left side. And then since we have our 5.5 plus TD equals TH, we can plug in 5.5 plus TD for TH. So 1.5 times 5.5 plus TD equals 18 TD. Then we're going to distribute that 1.5 times 5.5, which you end up with 8.25, and then we'll distribute that 1.5 times TD, so you have plus 1.5 TD equals 18 TD. And we subtract 1.5 TD from both sides, and we have 16.5 TD left on the right side of the equation, and we pull that 8.25 straight down. Then we're going to divide both sides by 16.5. So we end up with 0.5 or 1/2 equals TD. So 0.5 hours is the same as 30 minutes. And that's how long it took the leader to drive to pick the boys up from the river. So the hiking time for this would be 5.5 hours plus 0.5 hours is 6 hours. Since it took 5.5 hours longer to hike than to drive. We can calculate the distance just as before by saying the distance of the hike equals the rate of the hike times the time of the hike. So the distance of the hike equals 1.5 miles per hour times 6 hours. And that gives us 9 miles. So the boys hiked 9 miles. That's a really long hike, in my opinion. I don't know that I've ever been on a 9-mile hike, but I can see why it might have taken 6 hours, and you know why the scout leader thought maybe I should go pick them up before they end up out there in the dark. So so the driving distance will be the same, but we're just going to show it for completeness sake. We have 18 miles per hour times half an hour. You can cancel out those hours, and it's 18 times 0.5, which is 9 miles again. So it works out. Thank you for watching GalaxyPhi Math. Please don't forget to like and subscribe and comment and share to whoever may need this.